This study is on motion of charged particle in magnetic field. There are some diagrams which are based on the experimental observation and the conclusions as a consequence of them. The diagrams are depicted here. There is a conductor carrying current and a point charge nearby. The point charge in its vicinity. The point charge which can carry either positive charge or negative charge. Here the conductor carrying electric current, the point charge is kept nearby. Here the point charge is at rest. If the charge is at rest, there will be no effect on the charge by the flow of current in the conductor. However, when the point is in motion, when the point is set into a movement in the vicinity of the conductor, there we see some effect. It is a deflection of the charge. While the charge is moving, it gets deflected towards the conductor. If the charge carries positive charge, deflection towards the conductor. If the charge carries positive charge, deflection towards the conductor. If the charge carries negative charge, deflected in the opposite direction. It is a deflection in the opposite direction. It is deflected away from the conductor. Look at the difference. The charge should carry a charge, positive or negative charge, and there should be a movement in the vicinity of the conductor where we see deflection of the charges. If positive charge is deflected in one direction, negative charge in the opposite direction. That is about observations, experimental observations. It was first made by Lorentz, who discovered it, who invented it. Lorentz observed this repeatedly. So by repeated observation of this, and finally he came to a conclusion. Why this deflection on the charge while moving? He understood finally and concluded that there must be some force which drags the charge away from the path of the movement, which pull, that is a force which pull away from the path of the movement. That force is known as magnetic force. That force is also called Lorentz magnetic force. And that force arises, magnetic force arises due to interaction between the charged particle and the magnetic field present in that space. Charged particle, the interaction between the charged particle and magnetic field present in that space. Why the magnetic field is there? As I already know that from the Biot-Savart's law, when the conductor carrying a current induces magnetic field in its surroundings. You know that induces the magnetic field in its surroundings. These symbols represent the presence of magnetic field. And these both, what is that symbol? A cross mark in a enclosed in a circle and dot enclosed in a circle. The symbols says that there is a magnetic field perpendicular to the plane but in the inward direction. This side there is a magnetic field perpendicular to the plane in the outward direction like this. So this line on the plane, the conductor carrying current. So every conductor carrying current, in its surroundings magnetic field is present. This magnetic field can have interaction with the moving charge. That interaction produces a magnetic force. And the amount of force, what is that? With this interaction, here I said, Lorentz said interaction between the two vectors. The vectors is velocity vector and field vector. What is velocity vector? It is the direction of the movement of the charge. It is the direction of the movement of the charge like this. Velocity vector and magnetic vector, that is the line as direction as well as. The interaction between these two vectors produces one more vector, a resultant vector. It is a force vector, a magnetic force vector. So, on the basis of this observation, he proposed an equation. What is the equation? A mathematical equation, that is a vector form of equation for the force which can act on a particle. What is that? A charged particle moving in space where there is a presence of both electric field and magnetic field in the space. When a charged particle which is moving in the space where both electric field and magnetic fields are present, of course, the electric field and magnetic field lie perpendicular to each other, and these fields will interact with the particle and produces a kind of mechanical force that will pull away the particle from the position. That is what the magnitude of force, and it depends on the amount of the charge the particle is carrying. And magnitude, what is that? Magnitude of E, magnitude of V, magnitude of velocity. It all depends on the both vector and magnitude. But here the situation here we are realizing only magnetic field, no electric field. It is realization of only magnetic field, no electric field is present. That is E equals 0. If you put E equals 0, the equation reduced to this form. The force because of interaction between the particle and E and V here. When E equals 0, now it is a force because of only magnetic field. That force is called as magnetic force. Magnetic field, magnetic force. That is what the interaction between a charged particle and magnetic field. It is given by the expression that is called as vector form of Lorentz equation. Vector form of Lorentz equation. It has both direction and magnitude. There are two vectors, and the other vector is a resultant of these two vectors. Product of these two vectors. The product is a cross product of these two vectors, and the resultant vector is a force vector. So this resultant vector is perpendicular to this vector and this vector, but says what is that property of the cross product. Now, let us understand the direction of these vectors. Here, the force acting on the charge due to the interaction between the velocity and v. What is the velocity vector? Velocity vector is a straight line like this, entering the field in the straight line initially. That is called velocity vector on the plane line, and get deviated upwards because of the force arises. And another vector is a field vector. It is inward vector. It is perpendicular to the board. It is perpendicular to each other. This vector and this vector are perpendicular. And the resultant vector must be perpendicular to both these. What is the resultant vector? The resultant vector is a force vector is perpendicular. What is that? This line vector is perpendicular to the two vector. This is the direction of the force. Because force acting in this direction, that is the reason the charge is pulling towards this. If it is positive charge. If the charge is negative charge, the force exactly acts in the opposite direction. But again, perpendicular to both. What is that? This is a linear velocity initially, and this is a field vector, and the force here vector perpendicular opposite direction. This is the force. That is the reason it is deflecting in this direction. Says this equation gives us the direction of the magnetic force. What would be the direction of magnetic force? Why it is deflected like this? It is perpendicular in this direction. It is perpendicular in this direction. Resultant vector. So this is what we understood on the basis of this experimental evidence. This equation is called as Lorentz equation. It is a vector form of Lorentz equation. Now, if the charge is moving here at different points, here in this is what is that in the surroundings, magnetic field is there at every point. This magnetic field is not uniform. It is varying from point to point. The diffraction of the charge depends on the magnitude of B. Magnitude of B is not same. It is deviation, different angle of deviation, different points. Anyway, curve is there. That is what we visualize. Now, let us assume that is what in the surroundings like this. Different intensity of B will have different degree of deviation. Deviation is not uniform. Here, let us realize or assume uniform magnetic field in the space. Uniform magnetic field in the space. Uniform means at every point in the space, the magnetic field strength remains same. Magnetic field intensity remains same. Now the entry of the charge into the magnetic field, that is the entry linear. It is initially linear. It is deviated at all points. That is change of direction, deviation because of magnetic field. What is the deviation? Angular deviation. Angular deviation at every point remains same because this value remains same at every point. Uniform magnetic field. Finally, it turns out to be a what is that? That is deviation into what is a smooth circular movement of the charge. That is a smooth circular movement. It forms a circular with a definite radius, circular motion like this in uniform magnetic field. So, what happens here? If this is plus q, look at the direction of the movement. It is anti-clockwise direction. The linear motion changes into circular motion like this with a definite radius in uniform magnetic field, and the direction is what is that anti-clockwise direction. if the charge is positive direction. That is what you can realize by this experimental evidence. If the charge carries negative charge and in the uniform magnetic field, we can realize the same kind of what is our circular motion, but the direction of the circular motion is not what is that anti-clockwise, it is clockwise for this minus q. That is why. Look at this. Entry first in straight line and deviated forms a circular motion. The overall effect. What is the overall effect? Linear velocity changes into angular velocity. Linear velocity changes into angular velocity. Linear motion changes into what is that? Circular motion. Linear motion changes into circular motion in magnetic field. That is the effect of Lorentz force. That is on the basis this equation is proposed. And one more point we need to understand. He said the magnetic force, that is the vector law says magnetic F is vector is perpendicular to B and B. F is perpendicular to B as well as B. That means F magnetic force what it arises, it is always perpendicular to velocity vector, movement of the charged particle. If that is so, what happens? So any force does any work on the charge, if it is perpendicular to this, what is that? Will the force do work on the charge? No work is done on the charge if they are perpendicular. No work is done. If there is no work is done, the kinetic energy of the particle remains same. The kinetic energy of the particle remains same. This kinetic energy refers to the speed of the particle. Speed of the particle is directly proportional to kinetic energy. So, whatever the speed with which it enters into the field, with the same speed it is deviated, with the same speed it is circulated. Same. Only direction of velocity change. The reason, these two are perpendicular. That we realize from this definition. What the definition says, work is equal to force. Work is a dot product of two vectors, force into displacements. Force and displacement. So dot product means force into displacement into cos theta. Theta is the angle between these two vectors. And if force and displacement are perpendicular, the angle between them is 90 degree. That is cos 90. Cos 90 0 means 0. So force into displacement. But I said force into velocity. I am taking the displacement. So understand that displacement and velocity their directions remain same. Here I am taking displacement as a vector, whereby displacement direction and velocity direction remains same either way. So force into displacement or force and velocity vector, if they are perpendicular, then the force acting on the charge will not do any work, work equals 0. If there is no work is done on the charge, no transfer of energy. That is, no transfer of energy onto the charge. That is, no kinetic energy increase. Kinetic energy remains same. Therefore, speed remains same. That is a concept very important. With whatever velocity the particle is entering the field with linear direction, it revolves, it is revolving in the circular motion with the same velocity. That you are what you understand this equation. Velocity vector It has both direction and magnitude. Magnitude remains same, only direction change. Linear direction into circular direction. So it is a change of linear velocity into angular velocity. In this effect is known as particle changes its linear velocity into angular velocity into a circular motion. That we understood from this study. It is a Lorentz force, magnetic force, which can produce this kind of activity, that is circular motion. And it is the equation specify this equation, vector form. So since it is a vector form of the equation, and if you write the definition for this cross product of these two vectors, we know that cross product is this into sin theta. V into B into sin theta. What is theta? Theta is the angle between V and B. Angle between the vectors V and B. So look at this. That is an equation you get. It is a scalar form of Lorentz equation. It is vector form of Lorentz equation. It specifies only the magnitude of the force. It specifies both direction and magnitude. So let us concentrate on this equation. Look at this. This F can have possible values, some possible values, varying between minimum and maximum. Minimum value is 0. Minimum value is 0. Under what conditions F becomes F becomes 0? Here the equation itself realizes. Equation itself perceive. What is that? When the F becomes 0, the Q equals 0, B equals 0. No? If Q equals 0, F equals 0, B equals 0, F equals 0, B equals 0, F equals 0, and theta equals 0. Sin 0 is 0, that also becomes 0. And one more, when theta equals 180 degree, sin 180 is 0. Under all these conditions, F becomes 0. That is what it is specified here. But here, magnetic force becomes 0. Here condition when Q equals 0, what does it mean? Particle neither carry positive charge, negative charge is neutral. If the particle is neutral, you cannot expect this kind of activity in magnetic field. And enter with velocity 0 when the point is at rest. That is why when the charge at rest cannot be affected. Fm equals 0. And one more, when the magnetic field itself is 0, that is 0. Then theta equals 0, angle between these two vectors equals 0. That is, they lie in the same line, same direction. The same line, same direction is parallel. One more possibility, where the angle is 180 degree. These two vectors lie in the same line but in opposite direction. It is anti-parallel. Anti-parallel, 180 degree. Under all these conditions, we have Fm equals 0. That is a minimum value. What is the maximum value of F? Maximum value of F. Here you see that value of F is 0 and it increases. It increases from 0 as theta value increases from 0. If the value angle between V and B increasing from 0 to 90 degree, it increases gradually, and attains a maximum when theta equals 90 degree. That is the variation. With theta equals 90, sin 90 is 1. The maximum value is Q into V into B. That the value of Fm is maximum, and multiply all these values of the quantities in the space. Maximum. They are perpendicular like this. So these are the possible values of magnetic field. That is directions. Force has both direction, magnitude, and the possible values of force 0 and maximum, varying from 0 and maximum, and that will be understood from this. And next one, let us understand the direction of the vectors. There are three vectors, directions of the vector. So let us continue with the next session. Thank you.